Hello and welcome back to our studies in physics. Up till now we've been dealing with kinematics in one dimension. So when we deal with an object's motion in one dimension and yet we're still dealing with vector quantity, we have the luxury of being able to distinguish the two directions by simply using the two signs that we have along an axis, a plus sign and a minus sign. So when we were in one dimension up until now, we could just talk about a displacement being negative versus being positive to distinguish the difference in direction between those two displacements. However, when we move into a plane or two dimensions, now we are talking about motion that could happen anywhere within this plane. Recall that normally x is the horizontal and y is the vertical on your axes. So it's no longer going to be sufficient to just use a plus and a minus sign to distinguish or to be able to identify the displacement of an object or the velocity of an object or the acceleration of an object when it is in two dimensions. So let's just use displacement and let's look at an object displacing from one point to another. So let's say that the object started off here. Okay, so it started off at position P naught. So there's position P naught. Remember that subscript naught, the little o, keeps track of initial, whatever it is. So this is position initial. And then the object ends up over here. So that's going to be the final position, P. So let's see if we can figure out the displacement. We can graphically represent the displacement because remember the tail of the arrow is going to be at the initial, the tip of the arrow will be at the final. So I can draw the displacement graphically as an arrow that points like that. So there is the displacement of the object right here. Now let's see if we can figure out how to express it in terms of our coordinate system. We need a coordinate system. So in two dimensions, we must have a coordinate system to be able to specify the vector nature completely, the direction part. So let's look at P naught. It has some coordinates x naught and y naught. And so this is going to be some x naught, and this is going to be some y naught. All right, so what about the final position? Well, the final position is going to correspond to some x, y, some final position x, and some final position y. So the displacement of the object, remember displacement, is always equal to the final position minus the initial position. Okay, so the displacement then is going to be equal to the final position P minus the initial position P naught, or x comma y minus x naught comma y naught. So the final position minus the initial position. So how do we deal with that in two dimensions? Well, notice that we have a final position in x and a final or an initial position in x. These two are coupled together to give the displacement along the x-axis. The final position in y and the initial position in y are coupled together to give the displacement on the y-axis. So we're still using pluses and minuses, but now what we're doing is using them both along the y-axis and along the x-axis. So the displacement then can be written as x minus x naught, on x-axis plus y minus y naught on y axes. And you saw in a previous video that I defined unit vectors to keep track of these words, x-axes, y-axes. So remember that the unit vectors, and you can look back at the previous video for this, but the unit vectors, x hat meant along plus x direction, minus x hat was along the minus x direction, positive y hat was along the plus y direction, and minus y hat was along the minus y direction. So those are the four directions that we can be moving if we're sticking to an axis or parallel to it. So then my displacement, as described on this graph here, can be written as x minus x naught on the x-axis plus y minus y naught on the y-axis. So if I had these exact values, what x naught is, what x is, what y naught is, and what y is, then I could come up with exact values for the displacement on the x-axis and the displacement on the y-axis. And you can see that this displacement is pointing in the second quadrant. So it should have a negative x value and a positive y value. In other words, if I put a little mini coordinate system right here at the tail of the resultant displacement, you can see that that does point in the second quadrant. So positive y and a negative x corresponds to the second quadrant. So this is how we're going to be dealing with the vector nature of these quantities when we are in 2 dimensions. We'll be looking at breaking these up into pieces along the x-axis and pieces along the y-axis, and then taking the pieces along the x-axis and combining them together with proper signs, taking the pieces along the y-axis, combining them together with proper signs to find the resultant piece along the x-axis and the resultant piece along the y-axis. So we will pick up here next time.